Okay, pre-calc, we are picking up right where we left off from section 2. Remember, there was no homework in section 2, so you didn't miss anything. And if you didn't hit pause on the video and write down these rules, let's talk about them. So the main thing is the typical graph of growth is if the base is larger than 1. And I hope that makes sense, because if you have a base that's larger than 1, let's say it's 2, that means it's doubling every year or every month or every 10 years or whatever the growth is. It could be tripling, could be 5% growth. But anyway, those are all numbers that are bigger than 1. It's when you get numbers that are smaller than 1 for decay. You may have even seen those in previous years with like half-life problems. If the base is smaller than 1, it's going down. So like a carbon dating problem would have the amount of carbon in a tree has a half-life of so many years. So the base is smaller than 1. So that's why we have no reflections on those two. But the moment you have one reflection, whether it's over the x-axis or over the y-axis, that's exactly one reflection. A base smaller than 1 with exactly one reflection will be a growth problem. And then a base that's larger than 1 with exactly one reflection will be a decay problem. And we can look at all of these in different scenarios. If our parent function, I'll just write it right here because I don't know where else to put it. So hopefully you hit pause and you wrote everything. This is a base that's greater than 1, and you can play around with the calculator. But if you have one reflection, if it's over the y-axis, it is now like this. So that's reflecting over the y-axis. Notice it's now a decay problem. But if you reflect it over the x-axis, I'll just put it right here, reflect over the x-axis, it's still going down. So it's still a decay. So what I do is I just think of this scenario and say, okay, well, if we have our parent function, so to speak, is a growth, if I reflect it once, it becomes a decay over the y-axis, and reflecting it once, it becomes a decay problem. Well, what if we reflect it twice? And that's really the next step. What if we reflect over both the x and y axis? And that's what this next portion is going to do of our notes. So, here's a problem where we have a base that's smaller than 1. So 2/3 is smaller than 1. Normally, it's a decay problem, but we have 2 reflections. So if we think about how the base is smaller than 1, it would typically, I'll just draw it right here because I want to examine this. And we reflect it over the y-axis first. It looks like this. But if we reflect that new one over the x-axis, I'll just kind of put it right here, it goes back to being a decay problem. And if you still don't believe me, you can go ahead and pull up a graphing calculator, whether it's Desmos or an actual graphing calculator. Just kind of typing this in. I forgot what it was now. Negative of alpha x can make a fraction for me. 2/3 to the negative x plus 2. I like to put in parentheses because if you use Desmos, you need parentheses. If you use a graphing calculator, you do not, especially if you're using this one. If I hit the graph of Zoom 6, you can see it's a downwards graph. And everything else we've talked about is still true, that you have a horizontal asymptote at your D value, shifted up 3. So sometimes you'll see me write a dashed line at your horizontal asymptote, HA. But anyway, what we're trying to examine is that you do have a decay problem like this, and this is very poorly drawn. And I can talk about the next one. I guess I just assumed you recognize the 2 reflections. Let me highlight where those 2 reflections are. You have a negative in front, so that's a x-axis reflection, and you have a negative up here. That's a y-axis reflection. And you can see all three of these problems have two reflections, because that's what we're trying to get at. But if you notice in this one, the base is larger than 1 with two reflections. So if I was going through this, as I mentioned earlier, if we reflect a growth problem just once, it'll be decay. Well, what if we reflect it twice? So let's put it right here. So growth reflected once becomes decay, but if I reflect it again, it'll look like this. And it goes back to being a growth problem. And if you still don't believe me, go ahead and use a calculator. Double check. So if I were to actually graph this correctly, and look for a horizontal asymptote, it is shifted up to, and has a couple y-axis reflection and an x-axis reflection. I don't know exactly where it crosses the y-axis, but let's go ahead and look at the answer key to see a better graph. Yeah, they had a positive y-intercept there. And then one more problem. You can see the horizontal asymptote was shifted down to the base is smaller than 1 with two reflections, and it came back to being a decay. So let's get a better rule then. And you know me, I'm going to share the answer key. Is a growth problem, we still have 4 rules. But if you have a base that's larger than 1 with no reflections or 2 reflections, and then if the base is larger than 1, I'm looking down here now, with exactly 1 reflection, whether it's the x or the y-axis, it is a decay problem. So how do we get a base smaller than 1? Well, if the base is smaller than 1, bigger than 0, it has no reflections or 2 reflections, then it's a decay problem. But if that base is smaller than 1 with exactly 1 reflection, it becomes a growth problem. So really soak this in. You'll have a lot of problems dealing with this, and it'll help you graph, in my opinion. I think it'll help you graph. So hit pause. I'm about to go back to the notes and work through some more. So just getting you to understand and give good reasons. We're back to giving good reasons in these problems. And your reason is as simple as, like a blank for is it growth or is it decay? And that's the thing, is you have a 50-50 chance. So I'm more concerned about your reason. Is that your base is bigger than 1 because the base is 2. You don't have to write down that the base is 2, but that might help some of you. And there's exactly 1 reflection. How do I know? There's only 1 negative. Now, if you wanted to be specific, that's fine. You can say that that exact 1 reflection would be over the x-axis, because a negative as an a value reflects it over the x-axis. It's below the horizontal asymptote. So normally a base larger than 1 is growth, but with 1 reflection, that becomes decay. Now, as you're reading through the directions, state is the growth, decay, give the reason, here's your reason, and also give me the horizontal asymptote. Well, the horizontal asymptote is y equals, it's always this d value, y equals 3. And I could even ask a different question. Are we above or below the horizontal asymptote? We should be below the horizontal asymptote. So as we look at the next one, again, you don't have to tell me the base, okay, but it is 0.25. What I care about is that that base is smaller than 1. So I want to see this statement, that the base is smaller than 1, and 1 reflection. I was really emphasizing exactly, and because the negative is in the exponent, it's over the y-axis. But a base smaller than 1 with 1 reflection becomes a growth problem. There's exponential growth happening here. And the last thing to mention is, where's the horizontal asymptote? horizontal asymptote at y equals -2. That is the d value in this problem. And then h of x, again, break it down. The base in the problem, I only care about 3/2. 3/2 is larger than 1. So normally that's growth. As you look at how many reflections you have a negative in front and a negative in front. So the base is larger than 1 with 2 reflections. So with 2 reflections, that's saying, hey, we're back to the beginning. It's normally a growth with 2 reflections is back to being a growth. And then one last thing is, where's the horizontal asymptote? That's the last value at y equals 3. If I needed a reason for what the horizontal asymptote is, I believe I'd be fine if you said it was this d value, because it's normally A, B, C, D. But I don't think I ever asked for a reason other than like, what are the context clues? And you might even say it's shifted up 3 or something like that. That H is shifted up 3. And we're back to end behavior as well. So as we're looking at this problem, a few words of advice is pay attention to this piece as well. Because if you're just looking at this problem, you might not infer that you had a y-axis reflection. But I need to have this direction in here, otherwise half of you will have a different answer. So that's why I have this little clue in here, so pay close attention to that. And if I go to the next one, there's another y-axis reflection. But then the third one down here does not. So I need that clue in there to help you out. So the growth or decay is pretty straightforward if you're looking at the graph. It's decayed because it's decreasing. Because we're using the clue that's given to us, not the clues that are provided that the base is larger than 1 with reflections. What I'm looking for is that premise. Now the left end behavior, I want you to go back to the way we talked about in an earlier unit, that I want to see this. Now if you notice, the left end behavior is the horizontal asymptote. So I need the value of the horizontal asymptote. Why do I need that? Is because that's going to be your clue, because C is this value now, that we know that C is equal to 2. Oops, I guess I could have mentioned that right here as well. Is the equation of the horizontal asymptote, y equals 2. If they ask for a specific conclusion about this, you can write because BC, a horizontal asymptote. I know I'm all over the place, so if I'm saying something confusing, please let me know. I'm going to change colors real quick just to kind of emphasize things. So the next one, I want, as x goes to positive infinity, the function, I just want the behavior. So you see how it's going down. That is telling me that we have a negative infinity. So all we can deduce about this problem is that the a value must be smaller than 0. Why? Well, because we're below the horizontal asymptote, we must have an x-axis reflection here. So a quick reason could be because we're below the horizontal asymptote. And probably the most difficult thing in this problem, this is my opinion, you could disagree, is what can we deduce about the b value? Well, we have a decay problem with 2 reflections, an x-axis and a y-axis reflection. That's why we need this information. So if we have a decay with 2 reflections, then that base must be between 0 and 1. And again, the reason is we have decay with 2 reflections. All right. Go ahead and try the next 2 on your own. But I have a little bit more to discuss, so I will make a second video to explain the rest of these notes. So see you in a bit.